Hi, this is Synthchaser with Synthchaser.com, here with the ARP Pro Soloist. And this is a customer's ARP Pro Soloist, and like many ARP Pro Soloists, it has a few voices that are dead or don't sound correct. The customer told me he had 3 ARP Pro Soloists, and he took them to a synthesizer tech who said that the ROMs that route the signal path for the different patches were bad. And he took the 3 Pro Soloists and kind of merged them into the best possible one ARP Pro Soloist, which is this one here. But there's still some issues with it. Fast forward to many years later, the customer sees that I have ROMs available for the ARP Pro Soloist and contacts me about getting the ROMs to do the replacement or possibly having me fix it. And while his tech that he used was very reputable, I have actually yet to see one of the ROMs in the ARP Pro Soloist fail. All the cases where I personally have needed the ROMs has been where the ROMs have been removed. I think people misunderstand the ROMs in these keyboards a lot. They're not traditional ROMs in the sense that they output 1 or 0. They have open collector outputs. So basically they allow a signal to flow or not flow. So if the signal that is being controlled by the ROM just isn't flowing, it'll look like possibly the ROM is bad. So I have a lot of respect for the tech who had worked on this before. I am kind of taking it with a grain of salt, and I'm not going to be tied to the assumption that the ROM is bad. So when troubleshooting Pro Soloist with dead, missing, or incorrect sounding voices, the first thing you want to do is you want to go through all the voices and listen to what they sound like, and make a list of which ones are missing and which ones sound incorrect. And I have a video way back, Synthchaser number 001, where I run through the voices on a working Pro Soloist so you can hear what they all sound like. So you can compare yours to that and see which ones aren't quite right. So in this one, the majority of the voices are working. So the ones that aren't working are the bass, which is completely dead, Fuzz 1, which sounds wrong, Fuzz 2, which is nearly completely dead, and saxophone, which is dead. All the others, they sound pretty reasonably correct. So there's a few ways to go about diagnosing your incorrect or dead patches. And the service manual for each of the voices has this flow chart, the voice flow chart, that shows which waveforms are being used, where the signal's being routed to, which resonators are being used, which envelope generator is being used, if it's being routed to the filter or the VCA. And you can follow, and it has these test points, and they don't really correspond to anything on the circuit board, so you'll have to map it from the schematic to the circuit board. But they show what the waveforms should be at all the different points. So you can just follow this along and see where your problem is when one of these doesn't match. Another thing that the service manual has is the truth tables for the ROMs. So you can see which signal routing options the different voices share in common. And if you're a mathematical genius, you can scan this table and go, aha, this is the line that's unique to those 4 voices, so let's take a look at this area. It's probably simpler just to pick one of the dead voices and follow it through, because if you have multiple problems, you're going to have a hard time finding things that are in common on this table. However, it doesn't take a mathematical genius to notice something in common with these 4 particular voices. So electric bass uses the dynamic pulse waveform and no sawtooth waveform. Fuzz Guitar I uses dynamic pulse waveform and a sawtooth waveform. Fuzz Guitar II uses dynamic pulse and no sawtooth. And saxophone uses dynamic pulse and no sawtooth output. So if you go through the service manual, you'll find that those are the only 4 voices that use dynamic pulse. So that would explain why on sax, electric bass, and fuzz guitar we have no audio, and because if there's no dynamic pulse, there would be no waveform. And then it would also explain why on Fuzz Guitar I we have kind of a quiet one, because we were only possibly hearing the sawtooth portion of that, not the dynamic pulse portion. So we have a good starting point of something we can look into. Now it still is possible that that there is a problem with the ROM, so that dynamic pulse isn't being enabled because the ROM is defective. But let's make sure first that the dynamic pulse really is being generated. So before we dive in here, I'll flash the schematic of the dynamic pulse converter. And what this section does is it takes the sawtooth waveform and the ADSR envelope, and it converts it to a pulse waveform of varying pulse widths to give a fuzz kind of effect. So then it brings it over to the logic gate Z16, where it's ANDed with the lookup value from the ROM, the enable dynamic pulse line. So there were 2 elements, you'll recall there were 2 elements that were used to make the dynamic pulse. One is the sawtooth input, the sawtooth wave, so that goes on the non-inverting input of op-amp Z21, so pin 5 of Z21, and if I can switch hands I can correct the scope here, so we can see that op-amp is getting the sawtooth waveform on its input. I'll hit some keys and you see the frequency of that changes, so that input is good. The other input coming onto the inverting input of that op-amp, so pin 6 would be the ADSR. So let's go to pin 6 here and we'll hit a key, and you can see that that jumps up and goes back down. If I were to zoom out on the time scale, we'd be able to see that that looks like an ADSR envelope. So let's do that. There we go. So the inputs coming into this op-amp Z21 are correct. So now let's look at the output pin, which is pin 7. I'll go back on the time scale so we're expecting to see something similar frequency to this. So pin 7 here, pin 7, there's really nothing there. So we're missing dynamic pulse because op-amp Z21 is bad. So let's take this board out, let's remove the op-amp, and we'll test it out of circuit. So here's the op-amp chip removed. It's got a part number like SL19988, and people email me all the time and they ask, I have a ARP with a part SL19 whatever, and I don't know what it is or where I can order it. Well, that was just a manufacturer's, I think this is, let's see, yeah, this is National Semiconductor, made ARP, I guess specially selected op-amps, probably, you know, low offset selected op-amps. So this particular one is a dual op-amp, and that's actually just a LM1458, and the single op-amp with the ARP special part number is just an LM301. So you can just replace them with off-the-shelf versions of those chips. You don't need to find this special selected one. So this is the op-amp that came out of that board, and we'll plug it here into the Synthchaser op-amp tester, and we plug it into the dual op-amp socket, and neither of the LEDs are working. I was expecting just one half of this chip to be dead, but I guess the sawtooth waveform can still function without, maybe not as well, but it can function, I guess, without its half of the op-amp working, apparently. To show you what a good op-amp would do in my tester, so this is this is a national LM 1458, so I'll pop this in the dual socket here. And the two LEDs for A and B flash to show that both op amps on that chip are working. So if you don't have an expensive, fancy linear IC tester, they cost like hundreds or $1,000. You might consider picking up one of these op amp testers. I still have some on my website. It's a great way to analyze the failure mode of your IC chips. And like in this case, we confirmed that, yeah, our hunch from the oscilloscope was correct. This op amp's dead, and surprisingly, both halves of it are dead, not just one half like I thought. Okay, so I put an IC socket here and a new Texas Instruments 1458. I didn't use that old one that I just showed you for demonstrating the op amp tester, but a brand new one. That's a kind of a pet peeve of mine, people who use old chips, used IC chips in making repairs. You know, if it's still in production, there's no excuse not to use a new chip. And you'll notice that I cut these wires. This is the one going to the touch sensor. This goes to the output jack. I just cut those. That's a really bad design move to have these wires soldered to this board. So if you want to remove this board, you need to desolder the output, the audio output and the touch sensor, and then when you put the board back in, you have to solder it back. There should be connectors there. On later ones, there is a connector, at least for the touch sensor. So I've cut those, and I'm going to crimp on some Molex connectors so this thing can be more easily serviceable in the future. So I've got this board installed back in the synthesizer now, and I've added the connectors here for those hardwired connections to make the board serviceable. And we'll take a look at the dynamic pulse output now, that pin 7 of this op amp chip that we just replaced. And there's a pulse there, and you see when the ADSR opens, the pulse width decreases. I'll make it a little easier to see. And by the way, we're listening to sax, so that voice is now operational. I'll turn the keyboard over and show you the others are working as well. So let's take a look at the missing voices. So sax was missing. Fuzz Guitar II was missing. Fuzz Guitar I sounded weird. Now it sounds right. And the bass was missing. So the ROM was good, and shotgun replacement of all the ROMs like the customer was considering would have been an exercise in futility, a waste of time and money, and potentially opening up you know, the possibility of damaging other things in the synthesizer as you work on it. So if you got voices out, the odds are the ROMs are not the problem, and you can troubleshoot them like I just showed you using the service manual and the voice flow, signal flow diagrams that are in the service manual. Track down the problem, and it's usually something pretty simple like an op amp, and that can restore several voices, and just repeat that process until all your voices are working, and then you should be good to go. This has been Synthchaser from synthchaser.com. Thanks for watching, and have a great day.